2025 predicted paper 2, everybody. If you're AQA people, I'm going to put a little video up here so that you can click this one. If you're OCR, stay on this one. Very quickly, if you're new to the channel, we're testing out an exam theory to see if we can predict what exam questions are going to come up. The theory is, if the content is on the syllabus and it hasn't come up in 2023 and 2024, there's a high likelihood it will come up in 2025. So the topics that haven't come up are thinking abstractly, OOP, data structures such as stacks, queues, and also A-star algorithms. To add to the topics which haven't come up, we're also going to go for consistent themes that come up. So what I've had a look through is all of the different papers from previous years, and the common themes that seem to come up are binary search trees, Dijkstras, recursion, general programming, merge sort and quick sort, and the big O notation. The rest of the video is going to be a collection of predicted paper questions, past paper questions on all of these different topics. But if you found this useful, can you please like and subscribe it, because it just helps me to know that I'm not just talking to myself. Anyway, let's get into it. Just making you aware of this, people. We've been hosting masterclass sessions before the exams. We've got another one coming up just before paper 2 on Tuesday, 7:30 till 8:30. I'm going to put a little link in the description where you get access to the masterclass, plus the online course, and I'm going to send you over some resources. You don't have to do it, but it helps support the channel. Anyway, let's get into the video. What we're going to be doing is we're going to be going through everything that you need to know for A-level computer science to do with OOP. But if you're just learning programming, this is going to give you a good insight anyway. So first thing, what we're going to do is we're going to make our blueprint for our object, which is going to be class, and then we're going to make a line. We're also going to go for setting up our constructor method, which is our most important behavior that we want to set up, because it allows you to actually create an object, which is where you do def init, which is kind of like initialize, that's what it stands for, and then you put a couple of underscores either side. You always put self in there. We'll come back to self maybe later on, and then we're going to set up a couple of attributes that we want this particular object to have. So we've got name, let's do age as well, then we're going to put a colon there. Now we need to initialize our attributes, which these are the characteristics of what we want it to have. The ones that you put in here is on creation. These are the ones that are going to be set. So when we create our object, I'm going to give it a name. We're going to put an age in there. But there can be other attributes that you actually want to set as well. So we're going to do a combination of the two of those. So we're going to say age is equal to that. So whatever I do. And then we'll go for, we could go for location, which I'm going to set as a blank value because we don't want to do that on creation. And then we're going to go DOB, and we'll also do a blank one on there. So that's our constructor all set up and everything there. The next thing that we're going to do is, which is a very, very common exam question, but also just a common skill that you need to use, is what's called using getters and setters. Now there is this topic about where you can make attributes protected, and you have to use getters and setters to change them. Now that's a bit of a different topic, and I'm not going to go into that right now, but I just want to give you the least amount of time that you can just start getting marks on your exam, and also just start learning and actually using OOP. So we're going to go into def, get, and then you're going to make one for each of your attributes. So getters is the method, the behavior, which allows you to see what the particular attribute is. So you're going to do bracket, self, colon, and it's the same format for every single one. So you just self, and then you just put the self name in there. And then you do the next one, def, get, age, self, and then you're going to return self.age. I'm just going to do one more. You could do one for DOB as well, but just to save some time, because it's the same on each of them, so just get location. Then what you're going to do is you're going to put return self.location, which is all good. So those are all of the getters. As I said, we could put one in for DOB, but we're not going to do that. And then we're going to do def. Make sure the indentation level is absolutely the same as mine. That's really, really important, because otherwise it won't work. Then we're going to do the setters. I'm only going to do one because it's the same on every single one, but just to speed it up a little bit. So we're going to do set, location, bracket, self. In your setters, what you have to do is put the attribute that you want to change, which is location. And then what you're going to do is you're going to do self.location equals location. And that will set it on there. Finally, we're going to do just a different method, a different behavior, which is going to be raw. And then we're going to do self we're going to do the number of times that we want it to raw. And I'm going to do print, speech marks, raw, and then I do going to times it by n. I'm also going to put a little space in there because otherwise it will be right next to each other and it will look a little bit weird, but that's not a massive problem there. Finally, so what we're going to do is here, because we've still got quite a bit to do, but we're going to do instantiation now. So instantiation, and I'm just going through all of the potential exam questions you could get on OOP, so you should be absolutely covered on everything after this, is we're going to instantiate the object. So instantiate means to create an object that is going to, just is essentially a fancy way of just saying create an object. So how we do that is we give the object a name. I'm going to call that line 1, and then I use the blueprint for our object, lion. Make sure that if you've put a capital letter, you also put that in there. And then I have to put the attributes that I want to set, which is name. So I'm going to put, in this case, we'll call it Fred the lion. And then we're going to put the age is 10. You can put the whatever values you want, but I've just put those in there like that. And then to actually show you how to use the setters and getters. So if I use the setter to set the location, so if I go set location, and I'm going to put that in Africa. And then we've also got line 1, and then if we use raw and we say that we want it to look raw 5 times, so we've got a different behavior. And then to use a getter, if I just put line 1 dot get location to show you, you could use your other getters, but I'll just use get location to show you that I've actually changed it to Africa. So if I run that, we can see here that we've got it's rawed and also that Africa is there. Careful again of the indentation. That's a potential problem that you can sometimes get. I actually made an error and had to do a little cut on this one because I accidentally put there was a little space there. That's going to be right up against the side. This one up at the top is there. So skills, just a review that we've done, is we've got creating a class, creating your blueprint, creating your constructor so that you can actually make your object, getters, setters, just making another method that is about whatever it is, instantiating an object, using setters, using the method, and then also using a getter. So we've done absolutely loads. But now what we're going to do is inheritance. So what we're going to do is de-indent ourselves completely, and we're going to go somewhere in between these two, which is going to be, we're going to do def, and then we'll do cub, and then to create the first part of creating the link between the two of them is we have to put brackets, and then we're going to put lion, okay, which is going to inherit all of these values in here. Let's have a quick chat about actually what inheritance means. So if you get a theory-based question, obviously if you're just learning programming, you can skip over this or ignore this, but it's essentially inheritance is this idea that there may be some methods and attributes that are going to be applicable to this particular object, or this class. So what we want to do is we want to inherit all of the different methods that we've used up here and then put them into here, which is going to be super useful because it's going to save us loads of time. We're also going to look at polymorphism. I don't want to overload you too much with keywords. I just want to see you actually using this and see it, and then you can start seeing it work, and that's a nice feeling when you actually start getting OOP working. So just code along with me and everything. So anyway, we're going to make our constructor, which always is the same format, underscore init. And then we just put the values that we want to set, which is obviously going to be the same name and age. But also what I'm going to put in there is I'm going to put in an additional one, which is going to be like that. Now, the second part to creating the link is where we are going to use super, which is a key function, okay? So is a key function, which means that I'm going to inherit from the super class, or sometimes known as the parent class. I'm going to inherit all methods and attributes from the super class or parent class, and the child class is going to inherit all of those. Just means I don't have to write them again. So then we put dot, and then what we do is we do underscore, and then we're going to do init and create our link with the one above. And then what I'm going to do is I'm going to put name and age. So what you're going to put in there is you're going to put name and age. You don't have to put self again because we've already put it here, and we've got playfulness as well. Then we go on to the next line, indentation. Be really, really careful. Notice that I didn't put a colon there, and what I did is I've gone on to this line here. What I need to do now is I'm going to just set playfulness just like I would any of my other attributes. So I'm just going to do self playfulness, and then equals, we can set this as like a score on creation, okay, so we'll do something like that, okay. Now, to show you this working, so how inheritance works, is we're going to go for, so we'll go cub1 is equal to cub, bracket, three things that we need to put in there, not two, because we're going to set, name is going to be Tim, we're going to set the age to 5, and then what we're going to do is we'll go for playfulness is equal to 10, which is just some random score that we've just made up, just to show you that it's working. So what we're going to do is, as you can see, I haven't got set location, I haven't got get location in this class, but I can still use it because it's inherited all of those different values. So I'm going to do cub1 equals, and then I'm not going to do that. I'm going to do dot, and then I'm going to do set location. We'll also set this one to, well, actually let's do somewhere different just to show that it's working. Let's do South Africa, just be a bit more specific. We'll use cub1 and we'll use raw as well, because that'll be nice, and we'll do that to 10. In a second we're going to use polymorphism to actually change that, and then we're going to use the getters. So we're going to go print, and then cub1 dot get, let's use a different one, so we'll use get name, just so that we can, as you can see, I got a little error there, and the reason I did that is because I put def instead of that one there. So because we're making another class, so just be careful on that one, folks, because, you know, even I make errors from time to time as I'm trying to go through and teach you all stuff. So if we click run now, you can see it's inherited all of those methods, even though we've not written them in there, which is really useful and time saving. It's used raw, and we've also used get name, okay? Now, next skill that we're going to do is polymorphism. So again, if you've want to write down the theory-based question on this one, the theory-based question is it's going to be saying something like, describe what polymorphism is. Polymorphism is where a method that we've inherited from the superclass in the subclass behaves differently to the one in the superclass, and this is achieved through overwriting. Now, what that means in common sort of English is that what we've done is we've overwritten, or we've called it the same name, and we've just changed what we want it to do. And let's say that maybe what I want to do is I want raw to give me double the amount of sort of double the amount of raws for the cub. So what I'm going to do is I'm going to put def raw self n, and then we go n, let's say n equals n times 2, and then we could do print bracket speech marks raw, and then I do times n, okay? And it's exactly the same principle, but you can see on here, if I put a little space in there, we can see that it raws double the amount of times that I wanted it to. So yeah, it just is that idea of making it behave differently in the way that we want it to, and that's the idea of polymorphism in action there. The actual final skill that we're going to do now is what's called aggregation, okay? So aggregation is where we create again, theory point, which is has a relationship with one of our objects, one of our classes, and it's essentially a way of creating a relationship, but not inheriting every single attribute and every single key feature with all of this. So you've still got a relationship, but it's just not as strong as like inheriting all of the methods and attributes, which you might not want to do. So let's have a look at doing that. We're going to do this right at the top. So again, put class, don't put def, and then we're going to do we'll do zookeeper, okay? And then what we're going to do is no brackets. We don't need to put that there because we're not inheriting anything from there. Create a constructor for it, so you get loads of practice on creating your constructors. Self, and let's just do self, comma, name. We could do something like zoo, and we're going to do there, and then we're going to do self.name equals name, and then we're going to do self.zoo equals zoo. Now, once we've done that, we can use getters and setters, so we can do def get, and we'll just do the one. So we'll do def get, maybe we can do get zoo, and we'll do self, and we'll do colon return, and then self.zoo. Okay, now to create a situation where there's a link between the two of them. Okay, now what we need to do is, actually it's probably going to be a better idea to put a little capital Z there. And then what we're going to do is we're going to aggregate our link. Another name for this is also containment. I don't know if in your exam board it might be to do with that, but anyway, we're going to put zookeeper, lowercase, speech marks there. Then what we need to do is we need to do setters and getters. So we're going to go, okay, so now we need to do the setters. So to create the other link, so we're going to do def, set, zoo, or we'll call this one set keeper. Then we're going to put self, and we're going to put zookeeper in there. Lowercase, self dot zookeeper equals zookeeper. Same as a normal setter. Then what we're going to use is a getter, which is actually going to let us use this one up here because we're aggregating the link between them. So it has our relationship. That's the keyword that you need to put if it's a theory question. So get keeper, self, colon, return. Now this looks a little bit weird because we're going to do self dot zookeeper. And then let's say that I actually wanted to use get zoo as well on top of that. Self, and then I would just use get zoo bracket like that. Okay, so I know it looks weird, but you're using the object and then you're using the method from that, so then you've sort of created the link. And then to put that all together at the end, we're going to instantiate our object of the zookeeper, which we're going to do zookeeper1 equals zookeeper, remember capital Z for the class, and then we're just going to set a name, so we're going to do Bob, and then he's at Chester Zoo, which I have absolutely no idea if there is a zoo in Chester, but we'll go with that. And then what we're going to do is we're going to do zookeeper1 dot, and then no, we're not going to do that. We're going to do line1 dot, and then we're going to set keeper, which is our method for setting it, and then we put the object in there, so like this, keeper1, creating that nice little link there. And then if this is all working, then we've got line1 dot, and then it's going to be get keeper, which then that will run that method. So fingers crossed, if I've done this all correctly, that should output Chester. Hey, there we go. So that is everything, people, that you need to know for your A-levels, or just a nice intro to everything. So creating classes, instantiating, making your constructors, getters, setters, inheritance, making methods, polymorphism, aggregation, and instantiating objects and actually using all of them together. So that is everything. Don't need to know anything else. Let's get stuck into it then. So footballers is what we're going to call our two-dimensional list, and we're going to put equals. Now to create a two-dimensional list, what you do is you put a square bracket and then you put another set of square brackets. If you have never seen two-dimensional lists before, check out my one-dimensional list video, which that will help explain a lot of these concepts. And what we're going to do is we're going to put a footballer's name. I'm going to show my age here. Rooney, comma, and then what we're going to do is just put a random number. I go in between the two closing brackets there, and then I put a comma, square brackets, and then I'm going to put Ronaldo, comma, just put another number, comma in between at the end there. Third one, which will be our final one, I'll put Messi in there, comma, and then finally 76 there. Okay, the next thing that we need to be able to do is to actually get particular elements out of the two-dimensional list. Now, if we just use print so that you get a idea for this. So if I put square bracket 0, which if you know your one-dimensional lists, you'll know all about this. If I click run, you can see here, that is going to give us the first item. Now, how it works is the Rooney list, they're like lists within lists. The Rooney list is 0. Ronaldo is position 1. This is position 2. So if I put in here, position 2, you can see here, that's going to give me the Messi list. Now, what you may want to do is, if you wanted to go for a specific item within it, so let's say that I actually wanted to get output just Messi, I put another set of square brackets, and then I'm going to put 0 there. So then you can see here, the first square bracket selects the list, the second one selects the item within the list. So if I wanted the number, I would change that to 1, just like this. And then we can use that, let's say if I made a mistake. So if I put footballers, square, and then I put square brackets, 0, square brackets, 0. And if I put equals, input, enter the number or enter the name of the footballer you want to change it to. And then what I do is I put print footballers. You'll see that what's happened there is it should have changed. So if I put in there, if I put Mark, I'll put Noble. There we go. So then we put that in there. That will then change the list for us. And so understanding the basics of how to take particular items out of there, how to change particular items is kind of the first skills. The next thing that what we're going to want to be able to do is what happens if we wanted to add like a whole new list to it. So let's say that I wanted to add another player in there. What I would do to add a whole new player is I actually worked out this little shortcut on here. So what we can do is we can do footballers equals, well actually no, we're going to go dot append, which is the same as adding an item to a one-dimensional list. And then what I would do here is you can put input bracket, and then you can put enter the name of the player to add. And then what I'm going to do is I'm going to go comma, and then I'm going to go for input int bracket input, and then I can say add the score you want to add. The final thing that I actually need to do as well is we need to put square brackets around this as well. So can you see just here, I'm going to put a square brackets there, and then I'm going to go to the in between these last two at the end here, and I'm going to put a square brackets there. So be really careful with that. Okay, and then we're going to click run. And then what we're going to do says enter the name of a footballer you want to change it to. So let's say this is the first one. So if I put in Noble, then we'll put in enter the name of the player you want to add. We'll put in Jared Bowen. There we go. And then add the score that you want to add. So if I put 35, you'll see that it's now added that at the end. If you take the square brackets out, it's just you won't be able to do some of the different things that you want to do with the list, which we're going to look at just now, which is how we use a for loop to output different items, and then also going for like updating particular items within it. So quite a common exam question might be with a one-dimensional list, what we can do is we can use a for loop. So if I put len footballers, which if you don't know what that is, what that's going to do is it's a special function which essentially outputs each item with, well, it counts how many items we've got, which is going to count the list. So it's going to go 1, 2, 3, and then our fourth position in there as well. What I might do is I might comment that out just so that it doesn't load it every time, just to speed things up. But then what we're going to do is footballers square brackets I. Now how that works there, I'm just going to, let me just comment this out as well. So to comment this out as well, people, you put 3 apostrophes around the areas that you just want to comment out and that you don't want them to use in that, and then it just means that it doesn't have to run it every single time. So that's just a little shortcut for doing that one. Footballers square brackets I, what that does is if I wanted to output the first row, I could do this, print footballers square brackets 1, print footballers. So I could do all of that. Now, obviously, when I've only got three values in there, that's okay to do that. But let's say that I had a list that has every player in the Premier League, or if I had just a very, very big list, it's going to take me forever to do that. So what I can do is I can use a for loop to help me. And what a for loop will do, I use my special function, which is len, which counts how many list items I've got. So 1, 2, 3, puts that in there, so it counts it for me. So that'll work whether the list is 1 million items long, 1 billion items long. It literally will put that in there. And then what I do is I can use the counter variable because that will start at 0. Remember, position 0 is Rooney, and it just does it all for me. So it's just a more efficient way of doing this. So if I run that now, you can see here, obviously it's going to go Rooney, Ronaldo, Messi, and it just does that in 2 lines of code. But if the list, as I said, was 1 million items, all I'd have to do is write those 2 lines of code and it would do the same thing. So that's why it's efficient to do that. But what happens if I actually wanted to take it a step further and I wanted to output Rooney, this item, Ronaldo, this item, so at each individual item within it. Now, the logic of this is going to be square brackets 0, square bracket 0, and then I won't do every single one of these, but you can see that this can very quickly start going up like this, and we can talk about the complexity of how this is going to make things a little bit more complicated. So then we need to do this, then we need to do this, and then it's going to go here, 2, 0, and then I might as well do the whole thing, and then you've got 2, 1 there as well. Okay, so that's the situation that I need to create, is that this value needs to stay the same and that needs to increase by 1. And then what we're going to do is then we're going to go on to we're going to change this into a 1, and that needs to be reset to 0, which has, it looks quite confusing. So how could we do this? We could do this with a nested for loop. The way that we do this, so with a nested for loop, I'm just going to make a little bit more, some new lines in here, just so I've got a bit more space. Okay, so the first for loop is absolutely fine. And then what we're actually going to do is we're going to do another for loop within this, which is we do for x in range. You can use whatever variable, but it's just I use x. And the thing is what we're going to do here is this needs to be the length of the lists, and this won't work if let's say that you add a 2, and then a 7. Like this list was like 7 items long. They've all got to be consistent. So what we can do is we can go with the so in here, then we can go len, and if you wanted to work out how many items in there, obviously we could just write 2, but if you wanted to do it this way as well using len, you could do footballers, and then you just pick one of the lists. So if you just did square bracket 0, what that'll do is that'll select that, and if they're all the same, it will put that in there like that. And then we just need to make sure that we put a colon at the end. And then what we're going to do, put square brackets x. Now you'll see if I also output counter I, just so that you can see this as well, and then counter x. So you'll see that, when I was talking about before, it creates the situation that we want where I is going to stay at 0, and then that's going to increment to, so it'll go 0, 0, 0, 1, and then once that's finished, it goes back to the top of the for loop. I now changes from a 0 to 1. This gets reset back to 0, and then it's going to go through this. So if we have a quick look, so we've got, let's have a look at that. Oh, I missed out a bracket there as well. So just quickly do that. What have I missed there? Oh, I think it's probably because I didn't put the print there. I didn't put the colon correctly, and I was trying to save time. But there you go. So just make sure that your indentation level's all good, people. Okay, so just so that you can see it all. So it's starting from here. So from this part here, the 76 is that part up there. So we've got Rooney, which is our first position, which is 0, 0, which you can see, can't you? 0, 0. 30, 0, 1. Ronaldo, 1, 0. And you can see that it changed from there to 1, but this got reset back to 0. And using these 2 nested for loops allows us to do that. And I would say that I see that used quite a lot. If you're just learning 2-dimensional lists and you're just learning it for this, but if there's like a test that you've got to use, so I've seen this used in sort of high level GCSE questions and also high level A-level questions, you do need to become familiar with using this. So that's a really, really important one. The final thing of what I'm going to do to show you how everything sort of fits together is the other common exam question, but also is a really good thing for you to sort of think about, is how, let's say that one of the exam questions that I've seen is what happens if we just wanted to update the numerical values in there. So there's a particular position in each list within the 2-dimensional list. How could we update that? So let's say that it was off by 5. So in the exam question, they're going to create some scenario where they're like, okay, this is off by 5. How can we increase each of these without going in and just being like, manually doing it? So the way that we would manually do it, again, is we could do square brackets, 0, square brackets 1, and then is equal to, when we could use our count, you know, if I was to say about, or I guess sort of count. So, you know, count equals count plus, and then in this case, if it was off by 5. So we could use the same logic with this. Footballers, square bracket 0, square brackets 1 plus 5. And then you could do the same. So footballers, this then needs to change from a 0 to a 1. And then we could do the same with this. Footballers, square brackets 1, square brackets 1 plus 5. And then we just need to do the same for the last one as well. So let's think about equals footballers, square brackets 2, square brackets 1 plus 5. Okay, so again, that's the situation that we want to create in our program. But so let's think about how we can do this in the most efficient way possible, because this is the least efficient way of doing it. And again, if you have millions of items, this isn't going to be something that you can do. We can use a for loop to do this. So essentially what's happening is the second value stays the same. This value changes. So we can use a for loop to help us do that, can't we? So we can go for I in range and then 3. Or I mean, you could use len. You could use len and then the list name, but we can use this. And then, if, as I said, if we know that it's going to be consistent with it every single time, it's in the same place, so we can do footballers, square brackets. And then what I'm going to do is so the first value is going to change. So we're going to use either, and we're going to use square brackets, and it's position 1. So that's always going to stay the same. And then we just put that in again. Square brackets I, square brackets 1 plus 5. So then that creates the situation for us. And then if we output this at the end, footballers, I'll do a quick for loop just to show that it's done it. Print footballers, square brackets, and then we'll go just I like that. Okay, so if I run that, what should happen is, oh, sorry, I should have deleted that. Anyway, get rid of that. So we can see here that what this has done is this has updated each of them with 5 more than before, because that was 30, that was 40, that was 43, and that was 81, and so they've got 5 more. So those are the 5 skills that I think that you need just to have a really good chance at answering questions in terms of if this is A-level, you know, maybe a high-level GCSE question, maybe a little advanced or a high-level GCSE, but still good to go for. We've covered all of those topics. That should give you everything that you need. And, you know, message me if there's anything else that you want me to cover with them. And we can start off at A and try and get to E. So step 1 is we just put all of the nodes in there, and we're just going to put A is going to be equal to 0 there. And the other ones, they have the little infinity symbol there next to it as well, because we haven't visited those yet. So remove A from the queue, and then we look at the nodes which are next to A. Now, as you can see, the weight of the line going from A to B is 7, and the weight of the line going from A to D is 3. So D goes to the front. So D's going to be the first one because it's a shorter distance. And logically, that's the way that we're going to go for it. So if it's shorter, that's the one that you always visit first. So D goes there. So put in for a 3 on that one, and then there's the idea of adding the distances together. Now, that can be a contentious point because some people find that a little bit confusing because they're like, well, but it equals 3. It's because A starts off as 0. With that one there, so that's why you would do 3 plus 0, which is going to equals 3, and 7 plus 0 equals 7. So that's why those values are there. We move B and D to the front of the priority queue. D is in the front because the distance is shorter. We've already talked about that. So that's step number 2 in there. So you just go to the nodes which are go next to your start node, and then you just go to the shorter one first. So we remove D from the queue because it's the next shortest space away. That's where we are in the search, and then we identify places that are connected to D. So identify the nodes that are connected, which is actually all of the other ones, which is B, C, and E. We change the values in those ones. So we're going to change B we do 3 plus 2 because the distance going from A to D is 3, and then the distance going from D to B is 2. So that's going to give us 5, which is a shorter distance going from A, just directly from A to B. So that is why now B changes to 5, because that is a shorter distance. So that's going to take us less time to go there. C, we put in the values for that one. So going from A, we put 3 plus 4 because those ones they take us to C, which is going to be 7. And then E is going to be 3 plus 7 in that one there. Once we've done all of that, we're now going to remove B from the front of the queue, because now we found the shortest distance, because we tried 7 at the start, and when we went to D, that we found out that it was actually a slightly shorter distance there. So now we're at B, and we're now going to run some checks and see, are C and E going through this route, is it any shorter? So we look at these ones and we calculate the distances. So going to C from B is 3 plus 2 plus 3. That gives us 8. This is not shorter than 7, so we're not going to change this value. E is 3 plus 2 plus 6. So 3 plus 2 plus 6, because there's the line there. That gives us 11. This is not shorter, so we're not going to change. And then we take the C off, because obviously we want to see if actually going to C is going to be a slightly shorter route than going to E than any of the others. So again, we just run the check again. So it's going to be 3 plus 4 plus 1, or 7 plus 1, I've wrote down there, which is going to be 8. This is a shorter route than going 3 plus 7, which was 10. So we replace that with E, so E is now going to become 8. And then we've done the search. So going through all of those different steps there is just about visiting the nodes that are connected to it, visiting the nodes, and working out the shortest possible routes. And the examiner, one of the things that I should say is, if you find a shorter route, there's nothing wrong with that. The examiner on the mark scheme actually wants to see that you've maybe crossed out that value. So you've crossed out the longer route, and then you've said this is the shorter route. So in the case of when we changed B, so the initial one was 7, wasn't it? When we were going from A to B, it was 7. So you'd cross that out, and then you've actually found out that going from A to D to B is a shorter route, so 3 plus 2. And it's just going through those steps, just visiting the nodes that are connected, and once you've done all of that, then you have found the shortest possible route to get to everywhere on there. But I mean, it was going from A to E, this one. Now, I'm going to go and trace through, I was having a look through some exam papers, and I'm going to give you some tips on there for how to do the A-star algorithm, because generally the resources, I think, are terrible for the A-star algorithm, and it's really, really complicated. So one of the quick questions that you do sometimes see is just, what are the similarities and differences between A-star and Dijkstra's? So similarities, they both find the shortest path. That's their job. They're both shortest path finding algorithms. The differences is A-star uses this thing called heuristics, and sometimes they ask you just a simple 2-mark question, what is a heuristic? And essentially a heuristic is, and to get the 2 marks on this one, is I want you to say, is it's a best estimate or a best guess, that's 1 mark. And it's just trying to shorten the amount of searches it has to do to find the solution. Now, sometimes this is unavoidable, and it is going to have to check every single node, like the example that I'm actually going to show you. But the idea with the A-star, so this is the thing that you want to know from this and why it's slightly different from Dijkstra's, is the principle of this is to try and find a general rule of thumb that is going to get us a good guess to finding the solution, so that we don't have to do as many searches. So yeah, in some situations it is going to check every single possibility, but in other situations it actually won't. So those are some of the main differences on them. As I said, what I'm going to do is I'm going to show you how to a question from a paper, and I'll trace through and show you some of the things where you can grab some marks on it. I think one of the things that is going to be useful as well is just making a note of this calculation which the A-star algorithm uses to work out which node it should visit next. And what it does is it uses the actual distance of the graph, so the edge weight, and then also the heuristic, and it adds these two together. If the number is smaller, it's going to be less taxing for it to go there. Now, in some situations, it won't need to visit every single possible route, and that's the advantage that A star has. It's not like Dijkstra, which actually goes through every single possible outcome to try and work out what the shortest possible route is. We use this heuristic, this rule of thumb to do this. So what I did is I had a little look through some of the exam papers, and we've got our start node, which is A, and we've got our end node, which is G. And what we need to do is we need to look at how we're going to get to G. Now in this one, you will be going through every single possible node because it's not a very big graph. But on a larger graph, and let's say that it was spread out over into all of these areas over here, one of the heuristics might be telling you to kind of head in this general direction. And so that you would actually possibly neglect going up this route. And that's what the advantage that A star algorithm has. Now, a lot of us get hung up on the fact that with A star algorithm, with anything, that we have to fully understand absolutely everything about it. And obviously that's the goal. But if you've only got a short time until the exams, and the only thing that you get is the similarities, the definitions of what a heuristic is, that's still going to put you in a great place to be able to get some more marks than if you hadn't have done. Now we're going to look at this example as well. I'm going to talk you through some of the stages, and again, you might be able to pick up a few different things. You might be able to pick up a 1 or 2 marks on this. If you get all of the marks on it, fantastic. That's going to be it. So let's have a little look at how we can go through all of this, and how we can start off at the start. We're going to start off at A, and how we could fill in a table and what some of the different things that we're going to put into the table. So first of all, the first node we visit is A. The distance is going to be 0 because that's where we're starting at. The heuristic is 90 because that's displayed underneath it. And then we just have to add the distance travelled and the heuristic together. So that's going to be 90. An area which I see a lot of students make a mistake on is that they add the heuristic for every single one of these. So it is, if you are stopping there, that is the heuristic you add to it. Okay? So some people would, for example, if I was visiting B, what they would do is they would do 21 plus 80, and then they would add 90 on as well. You don't do that. It's just 21 plus 80 because that's the one that we're visiting, which I'll show you in a second. So that's mistake number 1 that I see quite a lot. The previous node we're visiting is nothing because A is where we're starting. B. As I said, the edge weight from A, so we are visiting B because that is going to be the next one. It is a shorter route than going to C, so that's why we're going to go and visit B. So it's going to be 21. Then the heuristic is going to be 80, as we can see underneath there. Adding those two together, that gives us 101, and the previous node is A. Next one, C. So we're going to go for C because that's the other one that's next to A. So we're going to go for 42. The heuristic is 65, as you can see underneath here. And then if I add those two together, that's going to give me 107. The previous node that I visit is A. Where it gets a little bit complicated now. Okay, so if you get those parts, so you can definitely grab yourself a mark for, so you get a mark per row, get a mark for locating the start node, putting in the distance travelled, which is always going to be 0 at the start node, the heuristic, just the thing underneath it, add them together, it's just going to be the heuristic, and the previous node is just blank or not available. Okay, that gets you a mark. If you can then work out what to do from that point, you can grab yourself a couple more marks there. So that's 3 marks there, people. This part is a little bit tricky, so let's just have a look at how we do this. So visiting D. Now there's a number of possible routes that we could use to get there. So first route I'm actually going to go for is, because B is shorter, I'm actually thinking that I'm going to be using that one. So if we have a look, it's going to be 21 plus 38. So we add those two together. And then what I'm going to do is I then have to add then my heuristic is going to be 50, so that gives me 109 there. Now, if I actually run the algorithm going the other way, so 42 plus 12, that actually gives me a smaller number, which is 54. I then add the 50 on, that gives me 104. This number is smaller. And in the mark scheme, they actually want to see that you've tried this one, and you've crossed it out. They don't just want to see that you've just gone straight to getting the correct answer in there, because logically, this is how the algorithm would actually go, is it would be going this way because it thinks it could be shorter, and then it goes this one, and it actually says, oh no, that one's actually the shorter route. So the previous node for this one is actually going to be C, not B. Calculating E. So for this one, it's going to make sense for us to go from B, because we're adding in a load of extra routes there. So if we were to go through D, so for that one there, it's going to be 21 plus 40, which that gives us 61. The heuristic there is 50, as we can see underneath there. We add those two together, that gives us 111, and the previous node for that one is B. So F. So again, just going through that, it's going to make sense for us to go to D. So we already know what D is, which is going to be 42 plus 12 to get us to D, and then we just add the 23 on there, which gives us 77. 30 plus 77 gives us 107, and then the previous node for that one is going to be D. It wouldn't make sense to go around the other way. So again, we don't have to go through all of the different other possible routes like we do in Dijkstra's. And then the last one, so G. So in this one here, I did do a little check just to make sure, and as long as you don't write it in the box on that one, you won't be losing any marks there. But the quicker route is going to be to go through the route of going through to D. So we go 23, and then if I add on 33, that's going to give me 110. The heuristic there is 0, so the answer is going to be 110. The other way round is actually going to give us 116, so that isn't going to be the shortest possible route. So the shortest possible route is going to be A, C, D, F, and then finally G. Okay. As I said, there are some super complex concepts on all of that, and with this, if you can just remember the start node parts, if you can, and then that then causes you to be able to look at what nodes are attached to that, and then looking at the distances going to those, that's going to be great. If you can grab yourself 2 or 3 more marks that you wouldn't have naturally have got, fantastic. If you can then push on to get all of the marks on there, even better. But just focus on what you can. If you can just remember the keywords, that's great. If you can get a couple of marks on here, great. If you can get all of the marks, great. Best of luck, people. Hope that was useful. Now, a couple of quick marks that you can get, which is just how to describe what a stack is. You're going to say it's an abstract data type, which we spoke about on the queues video, what that is. It's a LIFO data structure as opposed to a FIFO data structure, which means it's the last item that goes into it. It's the first item to come out of it. And you can have operations such as pop and push. Pop is the item that removes the item from the stack, and then push is the item that puts items into the stack. The 2 uses that I've put on there is undo and redo. So if you think when you're typing something on Word, and if you click the undo button, it will remove it. And if you want to put it back, you can click the redo button. And that's the idea of pushing an item onto a stack and popping it off a stack. Now, as I said, we're just going to focus on the creation of a stack, and also how to add data to a stack, which is the push function. The general operation of how this works is that you need to check if the stack is full to start with, because if it's full, we can't add any more items to it. And then if the stack isn't full, we can add an item to it. Now, I actually think the general function, how this works, is easier than queues because it doesn't require any pointers. You can do it with pointers, but generally you don't need it. So what we need to do is we just need to set max size to start with. So we're going to set max size to 3. Then all we're going to do once we've done that is we need to define our push function, which we're going to put stack in there, and then we're also going to put the new item in there. We can get the value from, we can get max size and make it a global and say that we want to use that because we may want to use this in other parts of the code. So I'm going to use that as a global variable. We've talked about scope and the difference between local and global and the benefits of using those. The other thing that we are going to want to do is, first things first, is check and see what is it that, so is it, does the size exceed max size? So the way that we actually need to do that to start with is we just get size is equal to len. And then len, what that will do is that will count the items in a stack. and then what it will do is it'll change that into a number, and then we can use that to compare it against max size. So if max size is equal to, if size is equal to max size, then what we know is that we need to output to the user that the stack is full. If that isn't the case, what we're going to do is there is actually room to add items to the stack. So what we're going to do is we're going to do stack dot append, and then we're going to put the new item in there. And then we might want to just say output the information to them. So just say put the stack, the current stack is speech marks, comma, and then just use that to separate it, just so that you can check and see it working. And then also we may want to return that back to the main part of the code. So we're going to return stack. Then we just need to initialize everything, and this is going to be like our main part of the code. So we put stack, we're going to get a new, if we put again equals y, while again is equal to y, and I'll show you how to do it with multiple items. So while that's equal to that, we're going to put new item. It's equal to input. Please enter an item you want to add to the stack. And then what you're going to do is, once we've done that, is we need to activate the stack. So we're going to do stack equals push, send the stack into that, and use that as one of our parameters. And then we're going to put new item like that. Once we've got all of that, we need to ask it if they want to add another item to it. So we're going to do again is equal to input, please enter y to continue program, or n to stop program. Then what I'll do is we'll just put a little message to the user, not indented, just saying program ended, just to notify the user that it's ended. And then we'll run it just to double check that it all works. So you can go run, please enter an item that you want to add to the stack. So if I put T in there, and what that's done is that's sent T, it's gone into there, it's checked, and as we can see, the max size is going to equal to that one. And then we can do, we'll do this, I'll show you max size and how that works then. So if I just go Y, yes, E, and then if I try and add another one now, so if we go for I, the stack is full, and you can see that it activates that and allows us not to add anything else into the stack there. So going on with this, what we're going to do now is we're going to use the pop function. Now there is actually a pop function in there, but we need to make this slightly more complex in the way with stacks. The way that we're going to do it is with pop, we need to check if the item is empty first. So if the stack is empty, or if there's 0 items in there, we can't take anything out of it because it's empty. So what we're going to do is we're going to do def, and we're going to call this one pop function because pop already exists on Python. And then all we need to do is we're just going to send the stack into this one. Now we'll use global and max size. We don't actually need that. No, we don't need that. So we're going to go size is equal to len stack, and then we're just going to check if that's empty actually. So we're going to do if size is equal to 0. Then we're going to say print stack is empty. And then we're going to go for else. And what we then need to do is now what we're going to do is we're going to put our else part. And this is actually where we're going to take the item out of the stack. So in this, what I need to do is I need to write stack, and then I'm going to do dot pop brackets. Now, another way I was going to show you how to do a queue is you can actually set the position that you want to take out. And one way that you can do with a queue is you can always take from the front, and then that will progressively make the queue smaller and smaller. Now, with a stack, the pop function, because it is pre-made and works in the way we want to, is going to take the item from the back of the stack. So that's what we want. So what we're going to do is we're going to print that just so that we can observe the stack, and what we'll also do is we'll return it as well so that you can see how that works as well. So I'll return the stack, and let's make a program where we can go through this. So we'll allow you to either add items to the stack or delete item or remove items from the stack, I should say. So choice equals input, enter 1, 2, add an item, or 2 to delete item from stack. And then what we'll do is we'll put an if statement under here, and we're going to go if choice is equal to speech marks 1 because I didn't put int input. Go underneath, and all we need to do is we need to activate new item and stack. We will keep again where it is because we want that to happen irregardless of whatever's going on. And then what we're going to do is we're going to do else must have selected 2, so then we're going to go for stack equals pop function, not just pop function. And then we'll send the stack in there. And then that is everything there. So let's run that and let's see that working. So let's add a few items to the stack. So if I put in Y to the stack, yes, I want to add another item. And then I'm going to go R. And now, so yes, I want to continue. And let's see if I want to delete an item from the stack. So you can see it's taken the R out of it, which is exactly what I wanted to do because that was the last item in there. Okay, so what I would really recommend doing is have a play around with this. So first of all, let's get a couple of marks in right from the off, which is get some definitions down, because they might just ask you to describe what a queue is. If they ask you to describe what a queue is, you need to say it's an abstract data structure that is FIFO. So there's a lot of interesting words there. Let's make sure that we understand each of these. So an abstract data structure, so means that there isn't just a way in Python that we can create a queue. We have to abstract, so take the keyword abstract, and we have to use the parts which are important to a queue, remove the things which aren't important. That's what abstraction means. And that will allow us to create something that works in a similar way to how a queue needs to work. It's FIFO, which means it's first in, first out. So if you enter the queue first, you will be the first person leaving the queue. And a couple of things that it's used for are print queues and uploading images. There's lots of different things that the queues can be used for, but those are a few examples there. Now, one of the most, I would say, probably confusing topics or confusing features of this is it has to use, and I was looking through the different mark schemes, and it seems to be that they want you to make sure that it's using what's called pointers. So I'm going to show you how to code this, because I think if you're able to code this, whilst they may just ask you to describe how enqueue works, if you can code this and you can do it from memory, what that's going to allow you to do is that's going to mean that you've got a really thorough understanding of this. So let's have a look at how we do this. So what I'm going to do is I'm just going to initialize, just very, very quickly, the tail pointer and head pointer. The tail pointer is the one which is just pointing to the rear. So you could also call that the rear pointer as well, either or, that's absolutely fine. And then you've also got the head pointer, which is just the front of the queue. And these two numbers help us in working out where we are at this moment in the queue. So if we just initialize these, so what we're going to do is we're going to initialize the tail pointer. And we're just going to set that to 0. We're going to set the head pointer to, we'll do this one to -1. And the reason that I've set that to -1 and not 0 is because what that's going to do is that's going to actually tell us that the queue is empty. And that's one of the really, really important things that we need to tell the sort of tell the program. If there's not a way of checking whether it is empty, then we may try to remove an item from an empty queue. And that's really important with dequeuing, which will be in the next video. Then what we're going to do is we're going to define our function, which is going to be enqueuing. And what I'm going to do is I'm going to send the new item in there. So that's going to be one of my parameters. But I'm also going to initialize, actually I'm probably going to do this the other way around. So I'll do queue, so the actual queue, and then I'll do new item. Put a colon here. And then what we're going to do is have to say to this, that we want to use tail pointer and head pointer. Now I would use global tail pointer, global head pointer. And to be fair, I probably could have done that for Q actually. I could have done global Q, but I'm not going to in this particular circumstance. Now, if you don't know what global means, please do go back and check the functions lesson, because I talk about the difference of scope and how scope is where you've got global variables and local variables, which are the two different kinds of things that you can get in scope. And it just essentially means like, where can I use a data structure? If it's local, it is only going to be used in one particular area. If it's local to that particular function subroutine, that's where we're going to use that. Global is where you can use it in any part of the program. Now, if this is something that is used across the whole program, sometimes it makes sense to use global. Generally, though, we would normally try to use we would generally try to keep things as local variables or local data structures, because it allows us to use this concept called encapsulation. I'm not going to go too much more into that because there will be other lessons on this, and as I said, I've been through a few of these concepts before, so please do check those out. Then the next thing, so once I've got that, I need to check whether the queue is full. Okay, so with this one, I'm going to say that I'm going to only have 3 items in there. So what I'm going to do is, if tail pointer is equal to 3, that tells us that we've got 3 items in there, so that the tail pointer has been incremented 3 times. So what that tells us, we've got a full queue, and I need to tell the user that. So print queue is full. And to be fair, what sometimes might happen is we might need to return a value just saying that it's essentially full. So we might be saying that we could just notify to the user and just say queue is full, and that'll probably do that. You may have to return a value in some circumstances, but we're just going to notify the user in that way. Otherwise, though, we can add an item to the queue. Now, in Python, what we can do is we can use append, which is going to help us out there. So we're going to get queue is equal to, queue dot append, which append is just going to add the item to the data structure. So we're going to put that there, and we're just going to put the new item in there with what we want to add it to. So once we've got that there, that is then going to add that. And then what we need to do is we need to notify one of the different areas about where things are going to be. So the head pointer we need to increment that, but we only want to do it if the head pointer is -1. The reason being is that the front of the queue is not only going to change when we dequeue something. So when something leaves the queue, what we're going to do is we're going to increment that to say that the queue is no longer at position 0. At the start of it is at position 0. It's actually at position 1 or 2 or whatever it might be. So this is the only time that we actually need to, during the enqueue function, the adding part, when we need to change this. So we're going to go if head pointer is equal to -1, which it is in this case. We're going to search head pointer to 0 to say that this new item is now at the front of the queue. We also actually want to increase the tail pointer in this particular case as well. So with this, we actually want to say where the back of the queue is going to be. So in this case, it actually might make sense for us to start off with the tail pointer as -1. And then what we can do is we can just increment this. So the tail pointer, the back of the queue is actually, so tail pointer plus equals 1, because what that's going to do is that's going to say that the back of the queue is position 0, which is also going to be the front of the queue. And then if we then end up adding another item in there, what's going to happen is then the head pointer won't be incremented, because we only do that to initialize the queue. But then we are actually going to have to increase the tail pointer by 1, which then would mean we've got 0 and 1 positions filled. The tail pointer pointing to the back of the queue, which is 1, and the front head pointer pointing to 0, unless we've removed anything from there. Once we've done that and we've appended that, we may need to return the value. So we're going to do return is equal to Q. Oh, sorry, return is Q, not return is equal to Q. And then that should be everything in the everything in there. So we've got the tail pointers, the head pointers. What I might do as well is just output the tail pointers and head pointers, just so that you can see everything happening there. So we're going to do print. The tail pointer is tail pointer. Print. Or I could say the front of the queue is position. Okay, the tail pointer is, or the back of the queue. Just a bit back of the queue. There we go, front pointer. Head pointer, there we go, head pointer. So whichever you've called it, just make sure you call it the same thing. And then we just need to do the actual main part of the code now. So this is where we're going to create a blank queue. Then what we could potentially do here as well, if we go, we'll create it a while loop so that we can do that. So again, yes, while again is equal to yes. And we could do new item is equal to input. Please enter to the code. I'll change that one to Q. So we've got that there. Then we can just go for Q is equal to NQ, and then these the parameters we're going to pass, which is Q, and then new item. Lovely. Okay, and then just to show that it's worked and everything, will output Q is Q. Then we'll do print. What we need to do again, if they want to enter it again, enter another item, yes or no. And then we've got that there, and then we'll just, that'll finish the program. So program ended. Okay, people, just a couple of little tweaks. Just put the print statements here just so that we could actually see what was going on, and then I just put the return the queue afterwards. And if you wanted to only put 3 items in there, you just need to change that to 2 because it goes 0, 1, 2. But this is just going to do it for 4 items, and then it's going to say queue is full, and then it won't let you do any more than that. So let me just show you that working. So it's going to be Y. The queue is position 0, so that's that. So, and then we're going to add in another item, T. The back of the queue is that, yes. So B, and then it'll allow me to enter 1 more in. And then if I try and do it again, it will say queue is full, as you can see, and it hasn't let me enter O in there. So that is everything, people, just so that you can sort of observe it and see everything working there, people. But that's how you initialize a queue, but with different, sort of with the tail pointer, head pointer, rear, front pointers, however you want to call them. And that's how you get it to work and stop going over a certain amount of values. Okay, so in the next lesson, I'm going to show you how to do it with dequeuing though. So what we're going to do is we're actually going to start using our dequeue function, and we're going to look at a particular way which I use to take items out of a queue. I'm going to show you how pop potentially works with this, and yeah, we're going to just have a quick look at how this all kind of fits together. So we're going to define keep it on the same program as we were doing before, and then we're going to define dequeue. We're just going to send the queue into there as the only thing that we need to do. I'm going to use global tail pointer, global head pointer. Okay, so we need those. Now the first thing that we need to do is we need to check whether the queue is empty, because if the queue is empty, we cannot take any items out of it. So we're going to do if head pointer equals -1, or if head pointer is greater than tail pointer, which I'll show you how this works in a second, we need to output print is empty. Just let them know that it is empty and that we cannot add anything else in there. Then also what we need to do is then we actually need to do the dequeuing part. Now there's a few different ways that you can do this. I need to increment the head pointer and show that the item that was at the front of the queue is no longer at the front of the queue. So I do plus equals 1. I can then actually take the item out if I wanted to. So there's, as I said, there's a number of different ways that you can do this, but I think probably the easiest way of doing it is this one here, which is, so I think probably going to be the easiest way to do this is now that the head pointer is 1 ahead of where it was, all we need to do is we're just going to go print, and then we're just going to output the information. So queue, and then it's going to be head pointer -1 in there, and what that's going to do is that's going to go 1 behind, and it's going to just output whatever the item was at the front of the queue. And now that the head pointer has moved on, it's at the front of the queue has now changed. So if you needed to, you can return that value if you needed to particularly store that. So you just copy that in there. So you do queue square brackets head pointer -1, and that would have been the old front of the queue because we're minusing 1 from it. So if the front of the queue was 0, we've added on 1 to it because the new front of the queue is 1, and then we've taken 1 away from it so that we can output that. It's up to you whether you use that or not. You don't, in this particular case, that we don't actually need to do this, so we're going to do that. And that's one of the things I think with queues that people find quite challenging, is the idea that you don't actually remove the items from it, and then when we come on to do circular queues where you will start taking them out in particular circumstances. So let's just put this in here, and so that we can get the enqueue and dequeue part working. So let's give them a choice. So new item. So if I make all this move down, choice is equal to input, enter 1 to add an item, 2 to delete an item. And what we're going to do is we're going to do choice is equal to 1 if choice is equal to 1. What we want to do is we want to do all of these, which is going to be adding items underneath there. And then so once we've done that, so that puts that there, we'll make sure again is at the end of it, so that needs to be de-indented there. And then we're going to do elif choice is equal to 2. That's where we want to activate the dequeue part of it. So we are, in this particular part here, we're just going to do queue is equal to dequeue, and then we can just activate it like that, even though, so we could do it like that, or as we're not actually returning anything, we could just leave it as this actually. So we could just leave it as that. So dequeue. So what we're going to want to do in our final part of the code is we're just going to want to run it and just see it working. So let's see if we can add an item. Okay, so we're just going to add an item. We're going to type in Y, so you can see that the back of the queue is there and the front of the queue is there. Now what is going to happen is I am going to remove I'm going to remove an item. So yes, I do want to do that, and then I'm going to remove that, which that's removed Y from there. So now if you think about it, what's happened, the front pointer has now increased, so the head pointer has now actually increased by 1. So head pointer is 1, rear pointer is 0. So if we have a little look here, do you want to enter another item, yes or no? So yeah, we'll say yes, and then let's see if we can try and delete an item. You can see that it's worked out that it is empty, which it is, and that's something there which we can work with, and we can see that essentially that's how we can one of the ways that we can tell whether the queue is empty or not, and also if the head pointer is -1. Anyway, have a play around with that, people. That's got all of the pointers and everything working in terms of that. Okay, so we have got we've got binary tree, and it says identify the root node in the binary tree. So the root node is the one at the top. It's kind of like the reverse of a tree, because a tree obviously grows from the ground up. But think of this one here, the tops there. So 2005. is going to be the one there. The leaf nodes are the ones on the end. So if you picked, so we can go for that one, 1952. And then we've got 2000 there as well. The other ones that you go for as well as 2100, 2560. It's just got to be at the end of a tree, essentially. So any of those ones. Okay, so 4 students have been added to the binary tree. Let's have a look at this one here. So we've got adding 1420. So it's with binary trees, if it's less than, it goes to the left. If it's bigger than it, it goes to the right. So less than. And then you ask the same question again. So is that going to be less than? And they can only have 2 nodes. And then less than. So that's going to go here, which is going to be 14. Sorry, it's a little bit difficult to do it on here. So that's going to be 14 and 20. 2050, so bigger than. Less than, less than. So that's going to go it's going to go less than here. So that needs to go to the left of there. 2780, so it's going to go greater than, 780. And then finally we've got 2600, so greater than, and then we're going to go to here, which is then less than, so then it's actually going to go here. So I've brought this onto this page so that you can kind of see how it works. So essentially what the question's asking us to do is to traverse the binary search tree. And what we've got to do is we've got to compare breadth first and depth first. So I'm going to go through depth first because I think that's the more challenging one to understand. And it's a 9-mark question, this one. So the way in which we've got to think about this is it's the same pattern as we always do, which is like describe it, apply it, and then evaluate it at the end there. So do we understand what breadth first and depth first actually is? So what we can do is we can just quick description, talk about the nodes that are visited. As I said, the depth first one is a little bit more challenging. Depth first is this idea that what it does is it's kind of so the reason it's called that is because it starts at the bottom and kind of works its way along. So it's going to go 14, so it's going to go to this one, 1500. 1952, 2000, work its way around the outside. So it kind of does this tree first. So it starts here, works its way up. 1952, 2000, 1985, and then visits the top of that tree, which is 1920. Now here, so if you imagine, we've kind of done like this. 1985, there, okay. This is the part where people really find it quite hard, and this is just practice, just going over lots of different examples of this. We then have to visit the bottom left of the next tree. Okay, so we've got this tree over here. So essentially what we want to do is we want to come down here. I mean, you want to start there. So we've visited all of those nodes, and then what we're going to do is we're going to come across here. So we're going to go up to here. So 2050, 2100, okay? It's very tempting to cut across here, and then what you're going to do is visit the bottom of this, 2600, 2780, 2560, 2350, 2000 and 2005. As I said, I know that that's like, it looks crazy, but I would say the idea behind it is that we finish up on the root node. That's the last thing that we're going to do, and then the first thing that we've got to do is we go to the bottom left hand corner of the tree, go to the bottom left hand corner of the other tree, and you kind of work your way around the outside of it. So if we describe that, so we're going to say that depth first is where we start at the bottom left hand corner of the tree, of the left hand tree, and we work our way around the nodes until we finish at the root node at the end. And then probably what I would do to get the application marks is I would actually write down the nodes and the order which they're visited in. So 1420, 1500, 1952, so remember it's working its way around the outside. 2000, 1985, 1920, and then we're going to jump to the bottom left of the right hand tree, so then we're going to go 2050, 2100, 2600, and then we're going around the outside. 2780, 2560, 2350, because we're going around the outside, and then finally 2005. Okay, now breadth first I generally think is a bit easier to understand in this one. So we've got breadth first is where you go through the tree in levels. You start at the root node, and then you go from the left hand side of each node of left hand side of the tree and work your way across. So that's again description, now application. So it starts at 2005 because that's the first node. So we kind of imagine this is like level 1. Then what you've got is level 2. So then what the next things that we're going to visit is going to be 1920, 2350. Then we've got level 3, which is going to be 1500, 1985, 2100, and you're just working from left to right. 2560. Now, just be careful because, you know, in this case, it would have been better if what I'd done is I'd put the 1420 at the same level as this, and also the 2050, the 2780, because it kind of is a little bit misleading because these ones here are all on the same level. Okay, so just make sure that you're working left to right, and then 2600 should be the final one that we kind of go through on that one there. So 14 and 20, so it's all about the levels. 1952, 2000, put this over here, and then we've got 2050, 2780, and then finally 2600. Okay. Now, with the evaluative points, so obviously you get a lot of marks there for just going through and actually knowing what those ones are going to be there. And you've just got to have a couple of evaluative points which you can kind of talk about and maybe think to yourself about how, you know, a few things that you can say about them. I would say I'd maybe aim for at least 2. And then if you can go for more evaluative points after that. I would just have 2 solid points that I could make about both of them, and then if you can think about some more, get those in there. But remember, you're going to be having about, I would say, 10 minutes that you want to be spending on this. So if you think about it, if you're running way over, okay, just make 2 solid points. If you finish the paper, then go on with the rest of the paper. If you finish early, you can always come back and make some more points in this. So I'd just be going that breadth first, because it starts at the top, is more efficient trying to find the value near the top. And then the inverse is true for depth first. So depth first, because it starts at the bottom, it is much easier to find, or much quicker, I should say, rather than much quicker to find values that are near the bottom of the tree. Okay, so bubble sort will sort an array of 50 integer values into called numbers of array. State why integer values are stored in an array instead of separate variables. We can reference all 50 values using only one identifier. Okay, so that would be the thing about the main advantage of using arrays and lists. This is the bubble sort algorithm. So for here, it's going to be 50. Okay, and then we've got essentially a do until, which will always execute essentially once just to check it, and then it'll check the condition at the end, which if you're familiar with Python, this isn't something that we use in Python, but still, it's still going to be, you know, still something that you need to be familiar with. So it's almost like a back to front while loop. So the values that we're going to use are, we need to subtract 2 away from it on this one here. There are, I'll put out a video about all of the different algorithms on sorts searches. Also, we do have a little community, which I'll put some links in the description as well, which we talk about all of these things, go through the algorithms, and essentially you can just make flashcards about this and just learn these, all of the big sorts that come up, quick sort, merge sorts. But yeah, I'll put a link about that. With this one here, this is going to be temp value, which is going to hold the value temporarily. And yes, sorry, I need to put a capital V there, so just be careful on like capitals and things like that, where it's got this up at the top there. So temp value is going to be a placeholder from when we're swapping things over in there. This one here is just obviously, so this is where we're comparing a value in a bubble sort with how the bubble sort works. So if the value, we want to swap this over, so if the one before it is greater than the one immediately after it, we need to swap this over. So we're going to say this is equal to the other one, and then what we're going to do is then you essentially just put the value in here, which is going to be temp value, which is just going to temporarily store it. There is actually ways in Python now where you can do that all in one go, which is kind of, because yeah, Python's been updated so you can swap it over on one line, which is quite easy to use, but you still need to know how all of this works, because as you can see that they do put pseudocode and things on in there. So those are all of the different values there. Okay, so we've got a section here which is going to be about merge sort. So it says show how merge sort will sort this section, going through this. Now, with this, it says show how a merge sort will sort this. I would probably put descriptions, and I would put the numbers in the order in which it goes. So with all of this, I would say split all of the items up into 4s. So obviously you do split them up into 4, so it's going to be like 2, and this isn't anything to be doing with sorting them, because you have to get them individual to start with. So there's those over there, and I make a really clear distinction that they're together, and then these ones are together. Split into pairs. Just making sure it's really clear that you've got them all split up. So 2 and 12, 1, 9. Then you've got 3 and 5. And then we've got 15 and 7. Okay. Split into individual values. So then you've got 2. Essentially 2, 12, 1, 9, 3, and 5, which is this is sometimes what people forget. Sorry, it's automatically putting those dots in there. You don't need to put those in there, but for some strange reason this is doing it. So you've got individual values. Then it's this idea of, once they're all split up like that, then you need to sort them as you're pairing them back up. So pair and sort. So notice what I won't do is I won't pair them and then sort them. It's done automatically. So 2 and 12. 1 and 9, I mean, they're already kind of sorted because they're in the correct order. 1 and 9. 3 and 5. So it's only the last 2, which is actually, they'll get swapped around. So you'll see here, I don't pair them and then swap them. It's done simultaneously. And then let me just move this up so that you can see it. Pairs into 4s. Sort, so then that's going to give you 1, 2, 9, 12, and then over here then what you've got is 3, 5, 7 and 15, which is kind of the same order, and then you just pair the 4s up into 8s. Pair the 4s into 8s, which is now sorted. So then essentially it's just going to be a sorted. So 1, 2, 3, 5, 7, 9, 12, 15. So it's kind of, it's just one of those ones where it's just be extra careful, you know, make sure that you've got 8 numbers at the end. Yeah, that's all good. And just making sure that you're going through all of those different stages there with that. Okay, so on to the 12 marker, which is talking about each of the different algorithms in terms of insertion, bubble sort and merge sort. And we need to talk about the big O complexities and the suitability for each of these with sorting 10 values in there. So first thing, I'm just going to describe what each of these are. So bubble sort, take the item, the left, and compare it with the one next to it, and then swap if larger, or move on to the next item and repeat this process until the largest item at the end of first stage, and then goes back to the start and repeats process. So and then we've got insertion, is where we take the first item and place in new sorted list, and then repeat going through rest of list. Merge sort, where we split the list up and then pair up and sort as we are going through the list. So I'm just making sure, and sort as we're going through the list. Okay, so I'm just describing, making sure that they understand that I actually know what each of those sorts are. Then what I'm going to be doing is I'm going to be talking about how we are going to be, essentially with this one, we want to talk about the big O notations, which again is just, do you know what the big O notations for these are? You can obviously talk about the average big O notation, because obviously the best case scenario and worst case scenario. In this case, it isn't a very big list, so I would maybe be tempted to talk about the big O notation in terms of a best case for insertion and bubble sort, because there isn't many items. These aren't very good when there is a large amount of items, especially bubble sort is really bad. So I'd even make that point, and maybe you can make that later on, is the big O, which this is obviously the application part. Now, the big O notation, amount of searches in a best case scenario for insertion and bubble is going to be ON, which would fit this scenario because there are not many items in the list. Merge sort will always, well, not always, but on average, will have a n log, so O n log n big O notation. Okay, so you need to just specify to them, do you actually understand what the what the example of this is going to be and what the big O notation is? Okay, and then what I would start doing is, once I've applied it, so I get those application marks, what I'd then be doing is I'd be thinking to myself, okay, let's start making some evaluative points. So I'm just going to move this up, and I'd start talking about, you know, those things that I was saying earlier. So these aren't very big. This isn't, I should use proper English. This isn't a very big list, so may make sense to use insertion or bubble, because it is a small list and they perform poorly on larger lists, but on smaller lists you do not need to use merge sort and use a lot of memory. Or merge will always use a large amount of memory for any search, and because this, and because this is a small list, it may be preferable to use insertion or bubble. Okay, so again, make your points. Because you've got 12 marks, I would say just you've got about over 10 minutes to see if you can answer these questions. If you need to come back and then make some more evaluative points in there, is because you may want to actually say, well, merge sort doesn't need absolutely excessive amounts of excessive amounts of memory because of all of the sort of like having in really, really large lists, they would have huge amounts of memory, and this is a small list, so you actually maybe want to counter that point there. But I'd just be maybe thinking about, use the time, use the time available, and then don't run out of time on the rest of the paper, so then start going through that. So it may make more sense in, as I said, that you're talking about how the memory is there's going to be more memory usage in merge sort and in bubble rather than in bubble sort and insertion sort. So it might actually be better to use one of the other two because it's a smaller list, but you could then also make the point that actually it's not going to use huge amounts of memory. So you could talk about that, have more of a discussion, but remember you've only got a certain amount of time that you can actually use on this.